four scenarios we will focus on: when feedback is away from the target, when feedback is near to the target, number 3, when feedback is on the target, and lastly, when the feedback is above the target. Consider here an example. There is one pressure sensor which is giving feedback to the drive, and we put the target pressure which we need to maintain all the time. When the feedback is away from the target, the PID considers it as a greater error and it will accelerate the pump faster. What I meant by the error is the difference between the feedback and the target. However, if the feedback is near to the target, PID considers it to be a smaller error, so it slowly accelerates the pump. In the demo, I will show a comparison between these two. On the right side, we will see the feedback which is away from the target, and on the left side, the demo is for the feedback which is near to the target. Notice that this is just a simulation. In real system, feedback will not be so constant. Demo starts now. Notice how fast PID is regulating the speed. It is making the pump to accelerate faster to decrease the gap between the target and the feedback. On the other hand, the feedback is near to the target, so the PID makes a slower acceleration, because if the pump accelerates faster, overshooting can happen. So PID is preventing that overshoot. Similarly, when the feedback is above the target, PID tells the drive to decelerate the pump. If the feedback is above and far from the target, the faster the deceleration will be, as you can see in the demo. Now the question comes, what if the target is met? Then what will be the action? In that case, VFD will hold the speed constant at whatever frequency it got the target. It will hold that speed as long as there is no difference between the target and the feedback. In this demo, we can see the behavior. Just to summarize, the whole idea is get to the target and stay on it. The increase or decrease in pressure depends on demand in real case scenario. If there is a demand for water, the pressure will drop. So the drive have to speed up the pump. And if there is no demand for the water, the working pump will build up the pressure, and now the pressure will rise and the pump need to decrease the speed. So how about an idea to give rest to the pump in case there is no demand? That's where sleep and wake up function has a role. We can define that at certain frequency, for example 50 Hz, then wait for 30 seconds. If there will be any demand, definitely PID will increase the pump speed and it will cross 50 Hz. Otherwise the pump will be put to sleep. And when the pressure drops at certain level, for example 1 bar from the target, then let the pump start working. This is known as wake up function. In the demo, I will show the sleep and wake up function. The PID regulates the speed, and once it is below 50 Hz, it will wait for 30 seconds. You can see the pump has gone to rest. SLP indicates sleep. Now I will drop the pressure, and when it drops 1 bar and after 1 second delay the pump will start again. Now we will discuss parameters. In the first step, enable PID to yes. In second step, we need to define sensor or feedback details. Sensor type, like it could be 4 to 20 mA or 0 to 10 volt. Once selected, we need to define the unit. It could be bars, millibars, Pascal, PSI, and if we have other sensor like flow meter, temperature transmitter, it is also available in the list. We can select the appropriate. Now we need to define the sensor's low limit and high limit. For example, pressure sensor can range from 0 to 10 bar. So we need to enter 0 as a low limit and 10 as a higher limit. Now we are done with the second step of parameter setting. Now the third step is for selection. Who will decide the target, whether it will be a keypad or any external source like controller? We need to define in VFD parameters. Setting PID parameters, which is P gain, I time and D time, and setting sleep and wake up function. However, please note that for some application, this function is not suitable at all. So know your application very well before applying this function. Now we are all set to operate, but this last step should be considered. This step is about the safety of our system. In case the sensor lost its connection with the drive, then what will be the action? You need to decide the suitable action. You need the pump to stop and the drive to indicate alarm, or you need the pump to stay at a fixed speed. Sensor losing its connection could mean either the sensor is out of service, or power supply is dead, or there is a broken wire or loose connection. Lastly, we need protection against quick pressure buildup. It could be due to again the damaged sensor or actually something with the mechanical system.